All right, we're going to finish up our atmosphere notes. So the last time we met, we kind of talked about the layers, boundaries in the troposphere, the stratosphere, and the mesosphere. Now we're going to really hit each of the layers of the Earth specifically. So let's get our slideshow presented. This is the last page that we worked on. So for your notes, for troposphere, basically that's the lowest layer. So in your first little box, you're going to be putting this word lowest in the line. Most atmospheric air is found here and extends from 0 to 14 kilometers, is about 9 miles above the Earth, and then the air temperature decreases with height above the Earth. So think about altitude as you're climbing a mountain. The higher up you go, the temperature decreases. It's getting cooler. So for your notes, I want you to write the most atmospheric air is found here. It extends from 0 to 14 kilometers above Earth, or you could put 9 miles. And then you need to know that the air temperature decreases. So this is the keyword that you're looking for and filling in, decreases with the height above the Earth. The troposphere is the layer in which we live in. Virtually all weather occurs here. Virtually all weather occurs here. All right, so let's talk about weather in the troposphere. We've talked about winds is the difference between, pressures. Wind always goes from high pressure to low pressure. Winds occur in the troposphere. It's caused by an unequal heating of the Earth's surface. So when we talked about our land breeze and our cool breeze, the high pressure and low pressure, high pressure meaning the cold air masses, low pressure meaning the warm air masses. So for your notes, I want you to write that the wind is caused by unequal heating of the Earth's surface. All right, so moisture, which is water vapor, so make sure you're putting this as your keyword, water vapor. It moves through the water cycle. Humidity is the amount of water vapor in the air, and this depends on the air and air temperature. So some of the keywords that you need to be putting so far is that the humidity depends on the amount of water vapor in the air and the air temperature. Dew point is our next keyword. Dew point is the temperature at which water begins to accumulate. Accumulate, like we might have accumulation with snow, water, rain, ice. Those are some things with accumulation on surfaces. Water vapor and condense to form clouds. So the reason why we have clouds is due to water vapor. All right, so there are 4 main types of clouds. So in this picture right here, we see like cumulus clouds, nimbus, cumulus. So the first one we're going to talk about is the cirrus. These are high-level, wispy, curly, composed of ice crystals. So in this diagram, when we're looking at high clouds, this is what cirrus clouds look like. Cumulus are the mid-level, so we're talking about this area right in here. Mid-level, they're fluffy, dense, mostly composed of water droplets. Cumulus. And then we also have stratus. These are low-level. Their layers are like blankets composed of water droplets. So we have low right here, and like your stratus clouds. Here's an example of a stratus cloud. So for clouds, we're going to talk about the cirrus, cumulus, stratus, and nimbus. These extend through all levels, rain, storms. So your nimbus would be through all of your levels. It can extend through all levels. Here's your nimbus cloud. This is where you find your storms. All right, so one of the another layer that atmospheric layer we're going to talk about is stratosphere. In the stratosphere, air temperature increases with height above Earth due to the ozone, which is O3, absorption of sunlight. It's 14 kilometers to 50 kilometers above Earth. It's a very calm layer, allows for undisturbed flight. So when you're flying, that's when you don't necessarily feel the turbulence. The ozone layer found near the bottom of the stratosphere. So the ozone layer is found near the bottom of the stratosphere. So some keywords that we're looking at here: air temperature increases with height above Earth due to ozone absorption, the sunlight. We know that it's 15 kilometers to 50 kilometers above Earth. It's very calm right here and allows for undisturbed flights, like when you're flying with no turbulence. And then the ozone, it's a keyword right here, ozone layer is found near the bottom of the stratosphere. All right, the ozone gas, O3, absorbs solar radiation, releases it as heat, and it protects Earth from harmful UV rays, which are what can cause skin cancer and is harmful to humans. So again, for the ozone layer, it's in the ozone gases absorb solar radiation, releases it as heat, and then protects the Earth from harmful UV rays. All right, the next atmospheric layer we're going to talk about is the mesosphere. It's 50 kilometers to 80 kilometers of the Earth. Air temperatures decrease with height above the Earth, so getting colder. So air temperatures decrease. The coldest layer is negative 100 degrees Celsius. Coldest layer is negative 100 degrees Celsius. This atmospheric layer is what protects the Earth from meteoroids. Meteoroids usually burn up in this layer, so they never really make it through the mesosphere. The thermosphere is the heat sphere. The heat sphere. So make sure we're writing the heat sphere. It's 80 kilometers out into space. 80 kilometers out into space. Make sure we're writing all of that. 80 kilometers out into space in that first blank. The temperature increases. So it's increasing with height above Earth. Usually it's 1,800 degrees Celsius to 3,300 degrees Celsius. This is where you find northern lights, or why we have northern lights. The aurora borealis are the northern lights. Space shuttles orbit here, and the ionosphere is the lower part, and the exosphere is the upper part. So the ionosphere and the exosphere are both part of the thermosphere. The ino is the lower part, and the exo is the